Welcome to my talk, Communicating with Cops, in this entirely virtual couch version of RailsConf 2020. In this talk, we will explore using Rubocop to communicate best practices and provide education to developers in an automated fashion. My name is Kyle D'Oliveira, and this is my pup Gratch. I'm from beautiful British Columbia, Canada. I've been working on Rails since the pre-1.0 days, and I've been hooked on Ruby and Rails because of how great it is to work with the language and framework, but also because of how amazing the community is. I'm currently a staff software developer at Clio. Clio is a 13-year-old SaaS company focused on making legal software to help transform the practice of law for good. I work on their back-end infrastructure team, and my team has three major areas of focus. The first is scalability, so this is in terms of data set size, code base size, but also the number of developers within the company as well. The second is approachability. For instance, how long does it take for a developer to get ramped up in a specific area of the code? And the last is the overall developer experience working within all of our repositories. This talk will touch a little bit of all three of these areas. Back in the early days of Clio, when a developer was first onboarded, we used to have a project we made them do called the Pet Project. Clio is a platform that lawyers can use to manage their cases and contacts as well as various other things. We had a fake feature we wanted new developers to implement where they could allow lawyers to manage various pets as well. The goal of this project was to get developers used to working with our codebase and align them on issues such as consistent styling or behavior traps. For instance, we would often notice that new developers would sometimes skip things like pagination, and we'd be able to educate and they'd be able to learn by doing in this project. This project really did the trick of getting developers used to our codebase and getting them up and running. We would have some comments that happened on the pull request, such as what's shown here. In this case, someone was commenting that it's easier to read code if there's a new line separating these various context blocks. This comment in isolation is fine. Small and concise, there's room for discussion as well as potential disagreements. In other cases, developers might catch something that should be removed. In this case, someone found a method that didn't have any code in it, so that should be deleted. Again, this is a good thing. We shouldn't be committing code that isn't being used. This makes it harder to work with these classes in the future. But the important thing is that neither of these two comments really touched on the actual behavior of the code. The reviewer needed to make the comment and provide enough context to the developer writing the pull request to understand and agree, which is a lot of work, and overall, kind of unnecessary. But at the end of it, we noticed that these pet projects would become a dumping ground of all kinds of comments like this. The goal here was good. We were trying to use this as a mechanism for teaching, but it wouldn't be uncommon to see hundreds of comments on a pull request. Well, you may not have had a similar feature like this. I'm sure many of you have had a situation where pull requests from new developers to the company, or even new developers to your team, are littered with comments to align them on styling. Imagine being this developer who is writing the pull request. This is information overload. There are literally hundreds of pieces of information coming in that you need to process and retain. These are all things that are useful to teach and convey, but when it comes in as a big dump, it is just cognitive overload. Imagine if instead we took that information and provided it to the developer as they were writing it, or when they were trying to commit the code. If we did, the developer would have much more context of what is going on, and processing that information would be much easier. Also consider what it's like to be a reviewer. If you need to constantly correct style or common behavior traps, you may be very focused on calling out that instead of focusing on the behavior of the actual code. For instance, in Ruby, did you know that you can call super without needing any parentheses? The reviewer in this slide knew that and wanted to call it out. But in this situation, the parentheses are required because the number of parameters have changed. Imagine if all of the styling and common issues could be automatically caught and identified to the writer. The reviewer no longer needs to focus on making those kinds of comments and instead can focus on the actual behavior of the code, which can lead to much higher quality code and less bugs. There has to be a better way. We can simplify this knowledge exchange and remove the human element from it. We don't need to entirely rely on humans to catch these simple errors, which is error-prone and can be overwhelming. Further, we don't need to rely entirely on the tribal knowledge that a developer accumulates over time. Instead, we can codify that knowledge and use it to teach other developers at the moment that it is relevant to them. By doing so, we can keep bad patterns and inconsistent styles out of the code base forever. People make mistakes all of the time. This is code that someone at Clio wrote in early 2020, and it has a very subtle bug in it. This test, when run with a group of other tests, and run in a very specific order, can cause those other tests to fail. However, I don't want to point out what is wrong here yet. I just talked about removing some of the human element of teaching these kinds of lessons, and if I simply point out what is wrong here, I'm relying on my tribal knowledge to educate. I want to show what it would look like to automatically prevent this kind of problem in the future, so I will come back to this. One of the ways that we can tackle this problem is through linters. Ruby has a really fantastic linter called Rubocop that has a lot of community support, and it is a very powerful tool for static code analysis. However, I think there are some misconceptions of what can be done with a linter that I want to talk about first. I often see, when the idea of linting comes up, that people think about things that are purely style or code layout. While Rubocop definitely offers built-in cops to handle these rules, such as what you see here, for instance, it could be bad to have an empty else block, this empty block doesn't actually influence the behavior at all. Although it might influence developers reading the code and might make the code maintainable, but it doesn't touch the behavior. We can also have layout cops that look something like this. This is something that you can configure of what style you would like when chaining methods over multiple lines. You could either have methods that use a trailing dot or a leading dot, but again, this doesn't influence the behavior at all. But it does help make code look consistent. But linters can do so much more. We can use it to handle complex behavior, and as I mentioned, also provide education when it detects something that violates the rule. Looking back at that dot position rule, the one thing that is provided by Rubocop on top of all that is the ability to autocorrect things. Although it is not all of the cops provide it, many do. And I found many of the issues that can arise about trying to get a developer bought into using linters, particularly those that are controversial, is the ability to autocorrect. If you can autocorrect the code, it makes it much easier for developers to get on board since there's no additional work for them to do. But as I mentioned, Rubocop can do much more than simple style or layout changes. For instance, it can do security checks. For instance, did you know that there are some methods on the YAML class that are potentially unsafe and can lead to remote code execution? If you don't use a linter to verify this, this is something that you need to keep in mind every time there is a code review. Otherwise, it is a potential security risk. But with a linter in place watching for it, this is one less thing you need to think about. One less thing for the developer writing the pull request, and one less thing for the reviewer. And while this might not seem like a lot, as more and more of these rules are in place, this benefit can really add up. You can also do things like watching for code that rescues from the exception class. Most of the time this is not what you want to do. Likely you want to rescue from standard error or specific lists of exceptions. There is good reason to this, and I'll come back to this later. And I'm sure many of you have had to do a Rails upgrade at some point in the past. The community has built some cops to help with this as well. For instance, if you're upgrading from Rails 5.0 to 5.1, the format of how to send parameters and controller tests have changed. Instead of being reliant on the position of the arguments, it relies on the params keyword. So if you are in the process of an upgrade, you can not only add this cop to prevent additional uses of the deprecated pattern, but you can also use it to autocorrect the instances that were already in place. That is more work that you don't need to focus on. But the most powerful aspect of Rubocop, in my opinion, is that it's really customizable. Anyone can write their own cops, and you can use them to emit various warnings and provide just-in-time education to developers. You could write a cop that is highly specific to you or your place of work, but you can also write cops that are a benefit to the entire community. As I mentioned before, one of the best aspects of Ruby and Rails is the community. Not only has the community done a good job of supporting Rubocop, but the community has built lots of custom cops that can be immediately leveraged and used by all of you. Some people have dug into performance analysis and wrote a cop to help protect and educate against common performance gotchas. There are Rails-specific ones, RSpec-specific ones, things to look for in handling thread safety, and so much more. That customizability is really powerful, but it is hard to know where to start when writing a cop. So let's take a look under the hood about how Rubocop works. Ruby has really strong support for metaprogramming, and under the hood, Rubocop analyzes the Ruby code, generates an abstract syntax tree, and then provides hooks to run Ruby code on various parts of that abstract syntax tree. I'm only going to be doing a high-level overview of how an abstract syntax tree in Ruby looks, and if you're curious to learn more, there are plenty of interesting things you can learn about abstract syntax trees. There's also a gem available called Parser that provides a tool called RubyParse. This is an interesting command line tool that you can provide arbitrary Ruby, and it will convert it into the corresponding abstract syntax tree. However, this can look pretty complicated and hard to understand, so let's break the syntax down a little bit with a couple examples. Let's come back to this example with the dot position, whether or not we should have a leading or trailing dot. How does Rubocop handle this under the hood? Well, we first must look at the syntax tree generated by this code. The code is something.method, and what is happening here? This is a method being called, so it is represented by a send node. The send node has two or more children. The first child is the receiver, the second child is the name of the method, and the rest are the arguments being passed to the method. So here we have a method named method, so that is the second child. We don't have any arguments, so there are no children after that. But now we need to look at the first child. This is also a method call, which, as I mentioned earlier, is represented by the send node, and we recurse through this. So we take a look at this one piece of code as well, and we realize that this is a method being called with the name something, with the receiver being nil. So there you have it. This is the full abstract syntax tree for this one line of code. And if we wanted to guess what Rubocop would be doing after looking at this, we would probably need to watch somehow for a send node. We need to somehow check that it was being called on an object. And we need to ensure that the dot was in the proper place. This is the Ruby code that's powering that rule. Look how it's very similar to what I just described. Rubocop provides an onSend method that gets called whenever the send node is triggered. There are many of these that Rubocop provides. And this is just Ruby code that we can write regular Ruby to do whatever we want. We can take a look at the node and ask whether or not it contains a dot or an ampersand dot, so we know that it's being called on an object. We can check to see if it's in the proper position, and if not, we can add an offense and an error message. And if we run Rubocop on the file, we can see that the error that will be generated. This is a pretty simple rule, so the message is pretty simple as well. It informs the developer that the dot should be placed on the next line together with the method name. It also points at the exact file and line that it happened. The error message here doesn't tell us why. However, it is something that is entirely autocorrectable, so the why is a little bit less important. Developers can be informed that the change occurred, in what file and what line, but they don't have to worry about doing it themselves. And in fact, there are plugins that can be set up to run Rubocop inside of your editor, or you can run Rubocop with Git hooks so that the autocorrect can happen very close to when the developer was writing it. Okay, let's take a look at another example, one that's a little bit more complicated. This is that rule of checking whether or not we are rescuing from exception or not. In the previous example, we only looked at a single line of code. So let's look at what the abstract syntax tree of these lines of code would look like and see how Rubocop would perform this behavior check. So let's look at these 5 lines of code. The top of the tree is represented with a KW begin node. Assume the KW stands for keyword. And there are a couple different begin nodes, but this is what is rendered here. And there's only a single child to this node. Now, this is where the abstract syntax tree might be different than how you may read the code. The one child of the KW begin block here is actually the rescue keyword. The rescue node here has 3 children. The first child is what happens before the rescue. So in this case, it's this line here, and we know from the previous example that this is a send node with the method do something that is being called on nil. Now the next child represents the contents of the rescue block and is represented with the res body node. This node also has 3 children. The first child is the list of exceptions that we want to rescue. So in this case, it's an array of constants with the value exception with no namespace. We only have 1. The next child of resBody is the local variable name that we're going to provide for the exception. In this case, we haven't assigned the value of that exception to anything, so it is nil. The last child is the code of the body inside of the rescue. And we've seen this before too. This is a send node with the method name handleException that is being called on nil. And lastly, I mentioned that rescue has 3 children. So the last child is the contents of the else block, which you may or may not have known could be provided by the rescue. In this case, we didn't provide it, so it is nil. This is what the syntax tree of those 5 lines of code look like. And if we wanted to look at how Rubocop would power that rule to prevent rescuing from exception, we would need to look for the res body node. We would have to look for that list of exceptions, which was its first child, and we just need to check if any of them is a constant with the value exception. If we look at the Ruby code for that cop, we can see it pretty much does exactly that. Whenever we see a res body node, we take a look at its children. If it has no exceptions provided, so this is just a bare rescue, then this is acceptable. But if the list of exceptions were provided, we should take a look at each one and check if it's the class exception. If any of them are, we can record an offense. So if we run Rubocop, we once again see the error message. We can run this via the command line and see this message show up in there, or we can have it run in our editor and see that as we are writing the code. The message here is okay. It mentions what is wrong and how to fix it, but there's a little bit of information that's still missing. And it would still require a developer who is unfamiliar with this problem to go research to understand why this is a bad pattern. If you go look at the Rubocop documentation for this rule, you'll find a link that links you to a page that explains why these rescues could be bad. If you rescue from exception, you may also be rescuing signal exceptions, which may mean that your Ruby process may not exit when you expect them to. The developer would have to dig a little bit in order to find that. So in the most ideal situation, we want to be able to have this information readily available. So let's come back to that original bit of code that I laid out earlier that was problematic. Let's go through what it would take to codify why this is a problem and prevent this classification of issues from happening again. However, now I do need to tell you what's wrong with this code. The issue here lies in this line right here. On this line, we're assigning the value true to the permit all parameters configuration. Looking at that permit all parameters method, we can see that it's a CAdder accessor, which effectively means it is a global variable. Assigning a global variable in a test like what is shown can be okay, but the main thing is we didn't reset it back to the original value it was when the test started. So when that test ran, it has the potential to change the global state, which is why the subtle bug exists. So if we didn't set it back before, the proper code would look something like this. If we are setting a value to something that is global, we should be inside of a begin block. We should remember to cache the original value before. We should have an ensure block in case there's an exception raised in between. And finally, we want to reset the value of that variable to the original value at the end. There's a lot of steps here, and it can seem complicated, but it isn't too bad. Remember that Rubocop is just Ruby, and we can write tests for Ruby. This may seem a little meta. We are writing Ruby code for a class that's looking at Ruby code. But we can still take a TDD approach to build this cop. First, we can start with a little bit of boilerplate, and then we can write a test that states that if you are assigning a value to a global variable, the custom cop should consider it an offense. So now we have a test, and we can try to figure out what would a cop here look like. Well, what is the permit all parameters equal? That is a method call, and we've seen one of those before already. We can tie into this with the onSend method. We can add a guard clause to ensure that the method is something that does modify a global variable. This could be as simple as a whitelisted array of methods that could be considered bad. And then we can assert that this code has to be inside of a begin block. This doesn't fully implement the rule, but it does make our tests pass. Let's continue iterating over this. Okay, so if the assignment inside of the begin is not okay, we should add another test. So let's wrap that assignment in a begin n and assert that it does fail now. So now we can implement the behavior for this. Why is the assignment of the begin inside of that begin block not enough? Well, that's because we didn't cache the original value. Rubocop gives us the ability to navigate abstract syntax trees, so we can even look and grab the local variable names. So we can grab that local variable. If it wasn't present or someone did not write it, we can add an offense. And huzzah, our tests are passing again. Again, doesn't fully describe the behavior, but we're still iterating over this. So what makes the assignment inside of the begin block bad if it caches the value? Well, it isn't assigning the value back at the end. So let's write a test that has most of the pieces. We're in a begin block, we cache the original value, we have an ensure block, but what happens if we don't assign it back the original value? We should have an offense there. So this test should fail again. So now we have to implement that last piece. We should assert that the variable inside of the ensure block matches the local variable of the stored original value. If that isn't the case, we raise an offense. Okay, now our rule seems to work, but let's write one more piece to make sure that it's actually doing what we expect. So let's write one last test that asserts we have all of the pieces. We have a begin block, we have the caching of the old value, we have an ensure block, and we reset the value to the original. There should not be an offense here. And now we have a custom working cop. Now through this entire process, we have full control over what the error message is, and we can be as verbose as possible. So now when a new developer comes along and tries to write code that is the same issue, they can have the linter run as part of them writing the code and be provided immediate feedback on what they literally just wrote. This is fantastic. We can tell them that they modified a global variable and that this could cause a transient spec failure because they didn't save what the original value was. The developer already has full context, and we're alerting them to an issue that they may or may not be aware of. And this also means that the reviewers of this code don't need to worry about this in the future either, because that knowledge has become codified, and it is now a pattern that will stay out of the codebase forever. There's also another interesting consequence as well. Because this check now exists inside of the codebase, other developers can extend it to make it apply to other methods or in similar situations. We use cops like this all of the time at Clio. We have many different ones. Some other examples include things like this. At some point, someone made a constant that used time.now or 2 days from now. This constant would have its value set on boot, and it's typically not what the developer was expecting. because they were expecting this to always be 2 days from now. But someone made this mistake once, and we can prevent this from ever happening again with a very simple check. And we can also provide context and education about it the moment the developer writes it. We also don't need to just isolate to the code itself. This is Ruby, and we can write any Ruby we want. For instance, we have a custom rule that asserts that we're adhering to the Rails convention for naming things. In this case, we have a user class that's inside of a manage module. The developer made a typo when making the test file and accidentally made the test file plural. Well, we can have a custom cop that can check the file names and inform the developer that something seems off. They likely just wrote the test and have full context around the error that it is describing. Remember too that these rules are not dumping all of this information on the developer at once at review time. It's providing this education and context as close to the developer writing the code as possible. We have many custom cops that we set up at Clio, and we build new ones frequently. Other custom cops we have, for instance, teach people about bad stubbing patterns in specs. We have deprecated classes that we don't want people to inherit from, and we can provide context on how you can use the new classes instead. We can provide warnings for deprecated methods or methods we don't want used anymore. We can also provide why and what you should do. We can ensure that temp files are always closed and what are the dangers of leaving some of them open. And many more. Whenever we encounter a problem that's problematic, we aim to write a custom cop to prevent this pattern in the future. And we provide that knowledge to everyone, and our codebase continually gets better. So by leveraging the linter, we can get consistent style across our application, and we can guarantee that problematic behavior stays out. But because reviewers no longer need to focus on that inconsistency, they can focus on the code quality, which will significantly increase the quality of the code and result in less bugs. And we can codify all of our learnings. Rather than have to rely on a developer catching things and providing that education, we can start collecting these pieces of knowledge and have an automated system that checks for them. For things that are really common, it is possible you can even provide these tools back to the community and improve the code quality for everyone. Okay, so how do you get started if you're not currently using the linter? Here are some of the insights we have at Clio that has really helped us get buy-in from our developers and team. First, Rubocop comes with a lot of rules. Some of them may make sense, and some of them may be more controversial in your organization. You are not obligated to enable them all by default. In fact, you don't need to enable any of them if you only want to run custom code. But you can start with the pieces that make the most sense for you and enable those. Next, you can leverage autocorrect as much as possible. Although I didn't go over it with the custom cop that was outlined, you can also use it to implement your own autocorrect behavior for custom cops as well. When the rules are safely and automatically autocorrected, a lot of the disagreements about styles just go away. Who cares if you have a leading or trailing dot when you're chaining methods across multiple lines if Rubocop will just correct it for you and you'll end up with a consistent style. You want to provide as much feedback as possible to the developers as fast as possible. So do it in multiple places. Encourage the developers to set up linting in their editors so they can see everything in as close to real time as they're writing their code. If you use Git, set up a pre-commit hook that lints the changed or added files. Then you know the moment a developer tries to commit code, they'll get feedback. It's a little bit slower than the editor, but it will still provide feedback very close to when they write the code. You can also set up a continuous integration server that does a full linting pass. Our codebase at Clio is quite large, and this step only takes a couple minutes, so we run it in parallel with our test suite. This guarantees that all of the code in the pull request lines up with the expected rules. But lastly, and probably most importantly, we should treat linting as a method to educate and train other developers. If you want to get buy-in from an organization, you can voice how codifying developers' learnings and providing just-in-time education for them will keep out bad patterns and make all of the other developers better. Likely they will see value in investing time in a tool that can help make all the developers better and make code quality much higher. Thank you.